double angle identities. In the identity sine A plus B, angles A and B could be just about anything. So if angle A was 10 degrees, then I would put 10 here. And here, if angle B was 30 degrees, then I'd put 30 here and here. So they could even both be the same. These angles, they don't have to be different. They can be the same angle, then you would get this. So we can simplify this to 2a, a plus a is 2a, and here we have a sine A term, we have a sine A term here. This sine A is multiplied with cos A, this sine A is also multiplied with cos A, so the bits in green, these terms are identical. So we can simplify to this, and this is what we call a double angle identity. The angle on the right side of the equation, we've got angle A, angle A, and double the angle, 2A, is on the left hand side. That's always a 2. This identity needs to be memorized. So if the angle on the right was 10 degrees, and these are both the same, both 10, the angle on the left hand side, it's 2 lots of A, so it's twice one of these, so 20 degrees. And again, this is always 2, irrespective of what the angles are. If you know the angles on the left hand side, so this angle represents angle 2A, so angle A will be half, which is 40 degrees, so angle A is 40 degrees. So once again, this is your double angle identity for sine. That's always a 2. Let's test this in the calculator to see if the left hand side is equal to the right hand side. So this is the sine ratio for 80 degrees, that's the left hand side, and this is the right hand side, and we get the exact same value in radians. So if the angle on the right, so angle A, is pi over 3, then 2a, so we have to double this, 2 pi over 3. If the angle on the left is x, so x represents 2a, so a is half x, so this will be a half x, or you can put x over 2, and this is a half x. If the angle on the left is 8 theta, that's 2a, so angle A is 4 theta, so that's going to become 2 sine 4 theta cos 4 theta. We have something similar for tan, so from the addition angle identity for tan, if angle A and B are exactly the same, so I need to replace every instance of B with an A. So I need to change this to A, this to A, and this to A, like this, and then we know that's going to be 2A there, and tan A multiplied by tan A, so something multiplied by itself, you get something squared, so you've got tan squared A. In the numerator, tan A plus tan A, 2 lots of tan A, and that's always a 1 minus, and that's always a 2 in this double angle identity for tan. So tan 4 theta, so 4 theta represents the 2a, so angle A will be 2 theta, so we've got 2 tan 2 theta over 1 minus tan squared 2 theta. That's always a 2, that's always a 1 minus, and it's a double angle identity. You take the angle on the right hand side, we've got angle 2 theta on the right hand side, double it, you get 4 theta. So tan x will be 2 tan. Okay, the x represents 2a. So a will be half of this, half x over 1 minus tan squared a half x. Again, if you take angle A here and you double it, you get 2a. You take angle half x, you double it, you get x. You take 2 theta, you double it, you get 4 theta. And doing something similar for the double angle formula for cosine, again, if we replace b with the letter a, like this, because a and b are any angle, they can be the same angle, just like this. And then we simplify, because that's 2a, that's cos squared a, this will be sine squared a. So we get this identity. Now, we get 2 further identities here, because we know that cos squared a can be written as 1 minus sine squared a, which then simplifies to 1 minus 2 lots of sine squared a. So cos 2a is equal to 1 minus 2 sine squared a. And we can do something similar with the sine squared a term. So replacing it with 1 minus cos squared a, and we can simplify to cos 2a is equal to 2 cos squared a minus 1. So you have to memorize these 3 double angle identities for cos 2a. So as an example, if we have cos 6 theta, so that's the left hand side, on the right hand side the angle will be half. You've got 2a, you've got half of this, which is a. We've got 6 theta, half of this is 3 theta. So I could write any of these 3 on the right hand side, but using half the angle, which is 3 theta. Like this, this, or this. So just remember that the rest of the formula, like you've got a 2 there, that's always a 2. There's a minus 1, that's always a minus 1. There's 1 minus, there's a 1 minus there, it's 2 times something here, it's always a 2 times something, irrespective of what angles you've got. As long as you take the angle on the left hand side, to work out the angle on the right, you're halving, because half of 6 theta is 3 theta, you see 3 theta everywhere here. And if you know what the right hand side is and you're trying to work out the left hand side, it's always a double the angle. So if you have 3 theta, double that, you've got 6 theta on the left hand side. Now we can take the identities here and here, these two, and rearrange them to make cos squared a the subject here, and make sine squared a the subject from this, and you get 2 further useful identities. These two. It's worthwhile having a go at doing that. So take this identity here, rearrange it to make cos squared a the subject, and then do the same with this, make sine squared a the subject. Be careful with the signs.